Hi everyone, I'm Sarav. Over the last few modules I built an agent I'd actually want to use myself, a market news stock movement forecaster. In the next 10 minutes, I'll walk you through what it does, how it's put together, and, just as importantly, where it's honest about its limits. Let me start with the problem. Say you want a quick read on Apple over the next week. You open your feed and there are a dozen headlines, some bullish, some bearish. The stock's already moved, and somewhere in a 10Q there's a risk buried on page 40. Pulling that into one cautious view is genuinely hard, and the easiest mistake is to grab the first positive headline and call it a day. My intended users are people who feel that overload but aren't full-time analysts. Retail investors, finance students, junior analysts. The goal is deliberately modest. Take a plain English request and return a 5-day bullish, bearish, or neutral call for one US-listed company, grounded in real evidence, honest about its confidence, and clearly labeled as research support, not financial advice. Why does this need an agent and not just a clever prompt? 3 reasons. First, the data isn't in the model's head. Prices, moves, and filings have to be fetched live at runtime. Second, the task is interpretive. The same headline can be bullish or already priced in, and a single linear chain tends to commit early and then rationalize. Third, I wanted strict input rules. Only 5-day single company requests. And that kind of gatekeeping shouldn't be tangled up with the creative reasoning. Those 3 pressures, live tools, competing hypotheses, and a clean safety boundary, are exactly what an agentic design is good at. Here's the system, end to end, and the diagram on the right is the actual compiled line graph, not a hand drawing. It's 3 specialized agents in sequence, all sharing one type state object. The first agent is the guardrail. With a single structured output LLM call, it does 2 things. It confirms the request is in scope, a 5-day forecast for one US company, and it resolves the company name to a canonical ticker through Alpha Vantage's symbol search. One detail I'm proud of is a first result wins policy. The orchestrating model isn't allowed to keep retrying validation with reworded arguments to sneak something through. Anything out of scope is rejected right here, before a single expensive call runs. The second agent is evidence collection, an LLM tool call loop, which in LangGraph is a tool node the model calls repeatedly over 3 tools. The price tool computes recent returns, 20-day volatility, and a volume ratio. The news tool pulls articles with per-ticker relevance and sentiment. And the SEC tool runs a semantic search over 8K, 10Q, and 10K filings I've chunked and embedded into ChromaDB. You can see that loop on the diagram, where collect evidence cycles through evidence tools. The third agent is the tree of thought reasoner, those 6 nodes running straight down the diagram. I'll dig into it on the next slide. 2 things tie it together. Each agent's message history is completely isolated, so the evidence agent never sees the guardrail's validation chatter, and every model gets clean context. And those dotted lines are conditional edges. On a rejection or a data quota error, the graph routes straight to the end node instead of pushing bad inputs downstream. Let me say a bit more about memory, because it does a lot of quiet work. There are 2 stores. ChromaDB holds the embedded SEC chunks for semantic search, but most of the system's state lives in a single SQLite database of 6 tables that plays 3 distinct roles. First, it's a transparent TTL cache. Every external API call lands in one API cache table, keyed by request and saved with an expiry. 24 hours for daily prices, 6 hours for news sentiment, a week for symbol search lookups. On a free tier capped around 25 calls a day, that cache effectively multiplies how many forecasts I can run, because a repeat request for the same ticker hits SQLite, not the network. Second, it's an evidence ledger and audit trail. Every piece of evidence the system pulls is written to an evidence table, and a separate link table ties each forecast to the exact evidence rows it used, so any forecast is reproducible and traceable straight back to its sources. Third, it persists the forecast runs themselves, plus a separate evaluations table that my backtester reads and writes. So SQLite here isn't just a cache. It's the system's working memory, its audit log, and its evaluation store, all with 0 external dependencies. This is the part I'm most proud of. Instead of read evidence, emit answer, the reasoner runs a small tree of thought. It generates 3 competing branches, bullish, bearish, and neutral, and forces each to attach its supporting and contradicting evidence by ID. A critic scores them 0 to 25. I prune to the best 2, That's the beam. Pick the most defensible and write it up. The whole point is to argue all three sides before committing, which is exactly the failure mode of linear reasoning. And there's a deliberate bias in here. The system won't just default to neutral when things are mixed. Neutral has to earn it. That one design choice took the most tuning. A few decisions shaped everything else. First, splitting into agents with isolated message channels. The evidence agent never sees the validation chatter, which keeps context clean and gives me one place to enforce scope. Second, memory. Structured data goes in SQLite, unstructured filings go in a vector store, right tool for each. Third, and this is the one I'd most recommend to others, every LLM reasoning stage has a deterministic fallback. So if the model times out, hits a quota, or returns malformed output, that one stage drops to handwritten logic and the run still finishes. That's also why my whole test suite runs with no API key. And fourth, typed errors at the data boundary, so a rate limit looks different from a real bug. Because this lives near financial decisions, safety is layered, not bolted on. On the way in, scope validation and US equity-only resolution. On the way out, every claim has to cite retrieved evidence, and a not financial advice disclaimer is a non-overridable default. The model can't forget it. When things go wrong, they fail gracefully. A data quota outage aborts with a clear message instead of a stack trace. An LLM failure degrades to the deterministic path. And I kept a human in the loop exactly where it matters, when the ticker is ambiguous, when the request is out of scope, and when the data just isn't there. Everywhere else it runs autonomously. The key safety fact is that its worst-case action is a paragraph of text. Now the results, and I'll give you the honest version. The first batch of 10 forecasts has now matured over a full 5 trading day window, and the system was directionally correct on 4 of 10, 40%, against a 33% baseline for 3 classes. The method is simple and reproducible. I compare the predicted direction to the actual 5-day move using a 1.5% band, and a forecast is only scored once its full 5-day window has elapsed, so I never grade a partial window. Where it worked cleanly. It called SLM up about 10.5%, BAC up 3%, and on the downside, TSLA and CSCO both down around 5%. But the misses are the interesting part. There's a clear bullish skew. 6 of the 10 calls were bullish, and 4 of those reversed, and one painful tail. CoreWeave fell 18% against a high-confidence bullish call. Beyond accuracy, what's solidly demonstrable today is reliability. 24 offline tests on the failure paths, graceful quota aborts, full Langsmith traces, and every claim grounded in cited evidence. I want to be careful not to oversell this. 10 forecasts over a single week is statistically close to chance, so I treat 40% as a working baseline, not a proven edge. The harness is in place, and the bullish skew and tail exposure are concrete, measurable targets to improve. The full results table and a sample run are in the repos sampleoutputs.md. Everything's public on GitHub. Beyond the code, there's a README, a design document, and a fairly detailed codebase guide I wrote so that someone outside this program can actually follow the design. Plus the 24 tests and a CLI you can run yourself. The stack is Python with LangGraph and LangChain on OpenAI, ChromaDB and SQLite for memory, AlphaVantage and SEC Edgar for data, and Langsmith for observability. To close, the biggest lesson for me was that reliability came from structure, not from a bigger prompt. Bounded reasoning, deterministic fallbacks, and human oversight placed surgically did more for trust than any amount of prompt tweaking. What surprised me was how much the unglamorous stuff mattered. One of my hardest bugs was just a duplicate config file silently shadowing the right one. Next, I'd run the full backtest, move to a richer data source, and parse SEC filings more intelligently. Thanks. I'm happy to take questions.